So from today we are going to start vectors, and in this chapter we are going to discuss dot product, cross product, and scalar triple and vector triple product. But in today's lecture we are going to discuss basics and dot product of vectors. Okay, so let's start. First of all, a simple you can say terms that are scalar and vector. So scalar has magnitude. It can have direction, also possible, not also possible. But there is a law, that is vector law of addition, which you may have studied in physics. Vector law of addition, it doesn't follow. It follows simple algebraic or scalar law of addition, that is simple algebraic addition what you do. Okay, and vector magnitude is there, direction is there, and it also follows vector law of addition. Okay, so there's a simple you can say distinguishing factor between scalar and vector. Now talking about some of the types of vector. So first of all, let's talk about null vector. Null vector is simply also called zero vector, like this, but this showing this it fit a specific direction, but actually it is not like this. Just to show vector we use it like this, but it has arbitrary direction. Arbitrary direction means we cannot specifically say. Okay, null vector is this. Now talking about position vector. Now I think you know this. This is vector, this is called the tail, this is called the head. Okay. Simple as that. Position vector is a simple vector like this taken coordinate system. This is origin. Now some here is a point, that is 1, 2. So this vector OP vector is called position vector. It's the vector joining origin and the point. So we will write it as OP vector is equals to what you see in ij terms, ijk I think you know, I cap plus 2j cap, right? Now talking about we discussed position vector, right? Now here you can use some of the rules also. Okay, so you can draw another vector like this, OQ vector. Now you can say this. So using vector law of addition, you can write OQ vector plus QP vector gives you OP vector like this. Okay, so this is by the help of vector law of addition. Okay, I'm talking about negative vector. It is actually negative. We are negative of vector. See, magnitude cannot be negative. We are writing any vector as minus b vector. It means it has magnitude same as that of b vector, but direction is opposite. Like suppose this is b vector, so this will be minus b vector. Magnitude will be same, direction will be opposite. Okay. Next comes collinear vector. They are the vectors, like if you say A and B are collinear vectors, so then we can write A in terms of B, as you can say scalar multiple. You can write vector A in terms of B in terms of its scalar multiple. Like this vector is I cap plus 2j cap plus 3k cap. And suppose the B vector is 2i cap plus 4j cap plus 6k cap. So we can write A vector B vector as 2 times A vector. Okay, this is a scalar value. It can be positive also, it can be negative also, it can be fractional also. If some background noise is there, so I'm very sorry for that, I can't change that. So we can write it in this way, okay? And the another way to check the collinearity of vector is using a ratio proportion, which I'm telling you. Just give. So there is a vector. A vector is a1 I cap, b1 j cap. Yeah, you can write a2 j cap, a3 k cap. B vector is, suppose b1 I cap, b2 j cap, b3 k cap. Now if I'm saying A and B are collinear, or I need to check whether it is collinear or not, then I'll just find the ratios. A1 by b1 equals to a2 by b2 equals to c a3 by b3. If it is coming like this, it means the vectors are collinear in nature. Otherwise it is not collinear in nature. Okay. Now talking about coplanar vectors. Talking about coplanar vectors. Coplanar vectors are those vectors which are in the same plane. So we can write it as in the terms of two scalar multiples like lambda and mu. We will discuss about coplanarity of vector in scalar triple product in more detail. Till now you can understand that these are the vectors which have which are, you can say, lying in the same plane. So lies in the same plane. Okay. So these are coplanar vectors. I think these are the basics of vectors or the types of vector which we have discussed. Now we will discuss about product of vectors. So talking with the dot product. Dot product of vectors. So we write it in this term a dot b, which gives us mod a mod b cos theta, where mod is the magnitude. Basics of vector, like finding magnitude, I think you have studied in physics. Okay, so I'm not discussing here. But if you don't know, let me discuss also. If a vector is like this, okay, wait, c1, then magnitude will be like this. Hopefully I'm going in the correct direction. Okay, so a dot b is mod a mod b cos theta, where theta is the angle between a and b vector, like this. This is a vector, this is b vector, this is the angle of theta. Okay, now if we are required to find angle, we can just use that expression only, and we can use it like this. Now theta will be cos inverse a dot b over mod a mod b. Okay, so I think it is clear to you, and now we will discuss about projection of vectors. So, projection of vector a on b. So how we write? Like just take a vector, b vector. We have to take its projection on this. So we just take like this a cos theta, as you see the how we resolve the vectors in x and y direction. So this is a cos theta. Now this is b vector. So to write that projection vector, let's say b vector, we will write into this way: a cos theta into you can say b cap, right? Because you see this is an, I think, unit vector, you know. I said that you must know basics of physics, basics of vectors which you study in physics, right? So this is a cos theta, this is in the direction, and this b cap is the direction unit vector in the direction of b vector, which we can write for the projection vector. Okay, b cap is unit vector. Unit vector are those vectors which have magnitude equal to 1, and they are generally used to show the direction. Okay, so like this we can write. Now just using cos theta, which we have derived earlier, like this. So into b cap is b vector by magnitude. This and this cancelled, so both are magnitude. So we can write v vector as a dot b over mod b into v vector by its magnitude. Remember, this is the magnitude of projection vector. projection vector, and this overall is called a projection vector, which you can write in this way also, just combining. Okay, the shortcut is that if you have to find, just take p vector on c vector projection of, so we have to just take the dot product of b and c in the numerator, and in denominator we have to take the magnitude of the vector on which the projection is taken. Okay, that is a c vector. So like this we can write, and this will make it a projection vector. Okay, so both dot product of b and c, and on c means we have to just divide it by the magnitude of c vector. Okay, so this was the projection of vectors. Okay, and some more idea which you must have, like if theta is 90 degree and a dot v is 0, so we write I dot j 0, I you can say j dot k is 0, I dot k is 0, because these are the perpendicular to each other. They are mutually perpendicular. I j k are mutually perpendicular to each other. Okay, these are the unit vector, and these are mutually perpendicular to each other. So theta is 90, then this. Now talking about some more cases, like suppose theta is equals to 0. If theta is equals to 0 degree, then cos theta is 1. Since cos theta is 1, so we can write it in this way: a dot b will be mod a into mod b. If suppose theta is 180 degree, then a dot b will be written as minus of mod a mod b. And this is the case of parallel vectors. Okay, this is the case of parallel vectors, and this is the case of anti-parallel vectors. Okay, this is the case of anti-parallel vectors where the theta is 180 degree. Okay, so these are the case which I think you already know in physics, but still we can discuss it here. So this was the today's lectures portion, that is basics and dot product of vector. The next lecture will discuss about the cross product of vectors, and then we will discuss about scalar triple and vector triple product of vectors. Okay. So thank you so much for joining in this session. In next session we will discuss about cross product of vector. Thank you so much. Bye bye.